Our next speaker is Vinicius. He's a backend developer with a focus on Python for the last 6 years. He's also very into QA. He's currently working as a software engineer at Zion Technologies. He also contributes to the community by translating the Python documentation to Brazilian Portuguese. He studied electrical engineering and software engineering, and also loves craft beer and riding his bicycle. Vinicius, the stage is yours.
Thank you. Okay, let's do it. I'll be presenting now about better functional tests with APIs and BDD, or behave. Well, since I've been presented, I'll just skip this part, or just one small request. Anytime you go outside, please wear a mask, because the pandemic's still going on. Lots of people don't wear masks, so please do when you're outside at least, and wash your hands as much as you can. About the motivation for this presentation. Once upon a time, JavaScript, a front-end bug, slipped through our quality process and made its way into production, making it possible for a customer to achieve what he wanted. If I'm not mistaken, he couldn't edit or create a new domain, I guess. After we fixed that bug, one of our software engineers decided to find a way to prevent that from ever happening again. And then we started to implement functional tests. And then there was Caffeine. Caffeine is the project name that we created at Azure. It is a solution based on Test Cafe framework. Test Cafe is a JavaScript testing solution similar to Selenium, but better, slightly better. And it was a major breakthrough for testing and quality at Azure, but as time passed, we started to notice a few difficulties with it. One of them, I might say, is that the tests started to get a bit corrupted, let's call it that way. And to better explain what I mean by corrupted, I'll quickly explain part of our stack. We have a big software which is responsible for handling the user interface and the APIs to our services. And after it, there is a dispatcher to pass information along. And that software is responsible for sending what is necessary to our edge machines. And the edge machines, of course, have lots of other softwares installed on them and are used by our final customers. Soon after we created Caffeine, we started to wonder, can we make some tests that actually test the response from the edge machine? We can, and in fact we did. And that might be one of the points where Caffeine started to drift off a bit from its original purpose. And testing the edge machines might not have been that much good of an idea. And some of you might ask, okay, but why don't you just stick with testing the user interface? Why not just unit test it? And to be honest, this image explained very easily. It's because our software, part of it at least, the admin interface, is a monolith. Everybody knows, use it, or love or hate a monolith. Maybe not that guy that's facing the horizon thinking there might be a better solution. In our case, the monolith is a Django application that's been going on with something like 6, maybe 7 years, continuously going on, receiving new features and fixes. So everybody that programmed with Django knows it's hard to test JavaScript or just the front end itself. One thing that we also notice is that the user interface is just subtle changes break the tests very easily, like changing any specific HTML elements to fulfill UX or products department needs start to break the tests. In this example, just replacing a specific list outside of div elements already broke tests at least once. And changing CSS also have the same effect. There have been maybe 2-3 times, something like that, where a developer refactors CSS classes with good intentions, but ended up breaking the tests. For example, just renaming RTM table contents to table content was enough to break the functional tests. And we use CSS selectors a lot, but they don't produce code that is very, very readable. Just by looking at this snippet of code in the left, you can't quite tell exactly what is being selected during the code. So that makes it hard to understand. And unfortunately, there are not many good alternatives to that. We could, and in fact we do, leave some comments on top of the CSS selectors, but that tends to make the code bloated, long. Instead of having maybe just 1-2 lines of code, we end up with 5, 6, sometimes more lines to explain what's going on during the test. And we can also use get elements by ID, which is a good idea, might be a good idea, but sometimes we have to go back and actually change the code that was produced to actually test it in a functional test. In some cases, maybe to some mistake of the developer passed during the code review, tests kind of rely on each other. For example, most of the times during the functional tests, we usually clean everything up, then create an entity, edit it, then delete, etc. So it's very common. There are a few, I think 2 or 3 scenarios where if you run the complete test suite, that's okay, it works great. But if you try to run just a single test, then it already fails. And that is because sometimes the tests are kind of chained together. You have to first create a domain, for example, to later on be able to edit it. The tests takes a while since we are waiting for a response from a specific machine, and then cannot be run in parallel. They take forever, mostly due to lots of interactions, like the server needs to decide what's going to be rendered to the screen, so it wastes CPU. There's a lot of stuff going on over the network. The browser needs to render what has just been received. So it would be really cool if it could run the tests in parallel, like we do with unit and integration tests for the main project to reduce the execution time. But in practice, we cannot do that because usually we run the tests against a stage infrastructure. So it's very possible for 2 developers at the same time run 2 different instances of the test execution. So they end up having a side effect on each other. They are hard to program. Even if the person writing the tests has some experience, they take some while because mostly due to response from the edge machines. And we're not exactly using standard HTML components. So you have to dig it up exactly what's the code that's necessary to pick specific elements and interact with them. So among running the tests 1, 2, 3, 10 times, that takes a while and sometimes ends up using a lot of time from the developer. Readability does count since there are lots of teams working in the project. So the architecture kind of got a bit out of control. So as I mentioned before with the CSS selectors, that makes the code hard to read and to understand. So as it is said in the PET 20, beautiful is better than ugly, simple is better than complicated, and mostly important, if the implementation is hard to explain, then it's probably a bad idea. And one thing that we notice a lot, at least my boss asks me a lot, where's the report? Where can I see the problem? not everybody have access to GitHub or GitLab logs, which is where the execution from Caffeine is kept today. So moving on from our current user interface testing, then we started with a new approach that might be more stable and is actually bringing a lot of more interesting results, which is use APIs and BDD. So APIs, probably everybody use it, read about it, wrote one or two. So this is not the biggest focus of this presentation. I'll stick more with the BDD itself. Our objective is to better explain our business rules. BDD stands for Behavior-Driven Development and is implemented using the Gherkin language. Gherkin is a domain-specific language originally proposed by the Cucumber lib, which helps to describe business rule in natural language without going to any details of the implementation itself. It's also very common to confuse it with the classic user story formats due to its structure, which is quite similar. Something like a user or profile desires something to achieve a specific result. In practice, BDD, as well as tests in general, are made up of preconditions, which is prepare everything you need to run a specific test, a trigger, which will be awesome if you have just one, but sometimes people write BDD with more than one trigger, and specific post conditions, which is check with assertions that our desired state was reached. To implement functional tests, we do not use the Cucumber language because it's for Java, but there are several other implementations for each language. With Python, we are starting our BDD with Behave. It has three basic parts, which are the features, the scenarios, and the steps. Features are mostly just aggregators or umbrellas to indicate which module or macro functionality is being tested. The scenarios is the name that indicates what exactly is being tested. And finally, we have the steps, which are the sets of individual actions to be performed during a test. They are the ones that actually are responsible for calling the Python code. I wouldn't be able to bring a whole complete scenario, so I just brought up a single step over here because it wouldn't fit a whole slide. We can see that the BDD itself, the step, is mapped to a Python code, in this case, the given, using a decorator. It says which part of the BDD is being used, and we pass along a parameter with a string with its description. In this case, we're about to log into our API, setting everything we need, getting back a token, and other informations that you need to carry on along the next steps or other tests maybe is used by creating variables in the context. Another great advantage of Behave is the features and the scenarios themselves already act as a report for the test execution with great readability. We even have the time where every step used during its running. It's very important, at least I think so, that each step executes one and only one action. So if by any chance the step fail, then we already know exactly what's the problem and what's going on to work on that. Another interesting feature that Behave and BDD is helping us is to document our business rules. Like the idea is to have a live documentation. For example, when a new feature is created or we are making a test, then that already allows us to also and automatically update the documentation. So, but why the APIs and not the UI itself? Mostly due to stability. If we make a change in the user interface, then the customer can adapt, work around of it, for anything that was generated. But with the API, it's not like that. every REST API that is available defines a specific contract with very specific rules. So we're accepting or waiting for these fields with this URI, and we'll provide this result. If you make any abrupt changes into the API from one day to another, then it's probably that we will cause trouble to the customer, as well as the automation that we have or the customer have. So we have to take a lot of care with that, like use version control for the API, protect with client flag, or other alternatives. Other benefits that we are noticing among this new approach is that it's starting to help us to decouple the front end from the back end, break the monolith, test exactly how the customer is using our APIs, thinking about developer experience in UX. Like, long gone are the days when our clients use it only and only the user interface. Nowadays, everybody wants to do automation, so it's very important to test your APIs. And even more important is better integration with other departments, for example, the products department, into creating test cases. Like, if we find a specific bug that was not documented in business rules, then write a test on it, and it's already documented, and fix it. One question that I got back at Asium is if we should stop testing the UI. Definitely not, we should not, but we can work on it and improve the way we're testing. Maybe getting back to its original purpose of testing just the JavaScript code itself. Oh, who knows, maybe fill it up with a lot of mocks and focus just on front end. And what's the current status of the whole project? Right now, it is located along with the monolith. Particularly, I'm not proud of it right now. This decision was made with the good intention that when a pull request was merged, we can actually trigger the complete test suite inside of the APIs. So this has not been done yet. Nowadays, it is executed daily with GitHub Actions, scheduled to run at 2 p.m. or 3 p.m. during nighttime when nobody's working, lower payload. So we just arrive in the morning and check if there are any notifications on Slack to see if the tests broke for any reason and investigate. And again, as my boss asked, where can I see the generated results? So this is one of the focus that we worked with this new approach. I don't know if anybody ever heard about Allure. I think that's how we pronounce it. It's an open source software for hosting reports. It's very interesting because we can see tests failing, trends, and very interesting data. I recommend, if anybody have time, to check it out. It's very easy to set up using Docker. Some other alternatives that I stumbled upon during this whole new approach. Originally, I checked it out to use Report Portal, but it seemed a bit more complex than Allure. So it's interesting. You got some batteries included, like AI to try to predict which tests will fail, so something like flaky tests. And this has not been executed, but it is on the radar to check if the tests run in parallel. Today, they're not running in parallel, but there is a library called Behave Parallel, which I'm particularly not that interesting to use. I'm a bit suspect about that because it has not been merged with Behave until today. I don't know if it's something like discussions in the community, something like that. And the last committee that received it was about 5 or 6 years ago, something like that. Or either is very, very stable or it's deprecated. But besides Behave Parallel, we're considering maybe migrate in the future to PyTest BDD, which enable us to run the parallel execution of PyTest. But interestingly enough, I don't know, Behave is more popular than PyTest BDD. I think it's because Behave is easier to set up than PyTest BDD. Well, to wrap it up, I assembled this little table over here that shows off that we had some difficulties with caffeine, and Behave is being very, very awesome so far. And a final advice that I recommend to anyone that is developing a new product: whatever you do, make it API first, because it'll make it very, very easy to test anything that you'd like. This is not in the Bible, just quoted here for fun facts to call attention. Would like very much to thank you for the opportunity for presenting here at PyBerlin. Thank you very much. Obrigado, gracias, vielen Dank, arigato. Still working on Chinese and Russian. If you can pronounce it, please do. A special thanks to Morgana from the design department to help me out with the design of the slides on the last days of the presentation. And if you have any questions at all about QA, software development, beer, riding a bike, please feel free to contact me. Thank you.
Thanks to you as well, Vinicius, for presenting this interesting approach. If anyone has any questions, please unmute yourself on Zoom and ask the question directly, or post it in the Zoom chat or Twitch chat. Samira is asking, you mentioned that the tests are scheduled to run in the night with GitHub Actions. Why schedule them?
Mostly to prevent any possible bugs to enter in production, since they are working on our stage environment. So we don't forget to run them before any deployment. So just to keep an eye on that. We could run them manually, and we do a few times when we want to check something out, but having them scheduled help us to prevent us from forgetting before deployment.
I have a question. So when you talk about API first, is there a good way to do this with Django?
Sure. Mostly the decision between going either with the interface or APIs is up to the developers, the company. In our case, the APIs arrived after some parts of the software. So nowadays we're working on having new APIs. I think the recommended way with Django would be with Django REST framework, which is not part of the main Django package, but it's easy to work on it. There might be some other approaches besides Django REST framework, but I think it's the de facto approach. Let's call it default. The default approach for APIs and Django.
Thanks.
Jose is asking a follow-up question on the one regarding the scheduling of the GitHub Actions. He's asking, why not running them before a pull request, something like CI/CD alike?
We could. In fact, we can. That's probably the original reason that I'm thinking about why we did it into the main repository. You asked running before, mostly because since some of the tests hit the edge machines, we don't have a specific infrastructure with all the branches on GitHub. We have a bit of a difficulty into raising all the necessary infrastructure, the edge machines. But usually we could, for example, immediately after the pull request is merged, the code goes to a stage environment, and you just wait about 3 minutes, something like that, maybe 5 minutes at most, and it is already available on the stage environment. After that, we could automatically run the API testing with BDD. But as it is right now, before the pull request is merged, we're not able because some of our tests rely on infrastructure.
Then I would have a question maybe regarding testing an API generally. I recently heard about a tool with which you can automatically test an API if you have an open API definition. Do you think this is a useful approach, and or does it have downsides compared to the approach you presented?
Might be a good approach. I'm not particularly sure about this tool. I didn't get the name of it. Would love to hear it, of the name. But automatic test case generation is very interesting, for example, into fuzzy testing, like hit your API with as much garbage as you can and see how it reacts. But this approach in specific with BDD, we are also interested in documenting our business rules. So it generates less test cases, but they are very target specific. Like we know this scenario should have this specific response.
Yeah, thanks. The tool is called Schema Thesis, I think. Haven't used it yet, but it sounded good.
Cool.
And Jose also mentions that Postman offers a way to do mock servers or tests based on an open API definition.
Awesome. That will be very interesting. We don't particularly document our whole APIs with open API standards, so that is something we're also trying to check it out.
I would like to thank you once again for being here tonight and taking your time to do this presentation. And then we will just go over to the closing session. So yeah, thanks for joining this year's second PyBerlin event. And thanks to our two speakers today for the very insightful talks.